So now let's do the next question. Okay, this question is very important because this question will give you an idea of to find the impulse response and the output of the system y of n. All right, so here the initial conditions are also given and the input is also given, right? So the question is, an LTI system is specified by the equation y of n minus 3 by 2 y of n minus 1 plus 1 by 2 y of n minus 2 is equal to 2x of n plus 3 by 2 x of n minus 1. When the initial conditions are y of minus 1 is equal to 0, y of minus 2 is equal to 1. And the input is x of n is equal to 1 by 4 raised to n u of n. So this is the input, alright? So the first part of the question is find its impulse response, right? Impulse response means, as you all know, impulse response means the h of n, right? H of n, alright? And the second question is also find the output of the system y of n. Okay, so what this second question actually means, what is the meaning of the second question? Also find the output of the system y of n. The second part of this question actually means that you have to solve this difference equation, right? You have to solve the difference equation, and you can solve it because the initial conditions are given and the input is also given, right? Because to find the output of a system you need two things. That is, first you need the initial conditions and you need the input, right? Because the output is divided into two types, right? There are two outputs that you need to find. One is called as the natural response or free response, and the other one is called as the forced response. Natural response means the output of the system due to the initial conditions alone. Due to the initial conditions alone, that is called as the natural response or free response. And the other condition and the other output is the output due to the input alone, and that is called as the forced response. Okay, so here, as we are doing this problem, I will be explaining you the theory behind this output response also. Okay, so you'll have a clear-cut idea, because sometimes in the exam they will ask you to find only the natural response or only the forced response. In that case, you need to apply only those conditions alone. You don't have to find the entire output. Here in this question, you have to find the entire output. That means just add these two outputs. We'll be doing this problem, then you will have a clear-cut idea how to do this problem. Okay, so first I will find the impulse response. So to find the impulse response, I have to find my transfer function h of z, right? So after finding h of z, take its inverse and find h of n. So let's do this question. Given, so I'm doing the first part of the question. So I'm going to find the impulse response. Okay, so given y of n minus 3 by 2 y of n minus 1 plus 1 by 2 y of n minus 2 is equal to 2x of n plus 3 by 2 x of n minus 1. Okay, so now I'm going to apply z transform to this equation. Therefore, applying z transform to the above equation, comma. So what is the z transform of y of n? It is y of z minus 3 by 2 into the z transform of y of n minus 1 is z raised to minus 1 y of z plus small letter y of minus 1. Okay, plus the z transform of y of n minus 2 is 1 by 2 into z raised to minus 2 y of z plus z raised to minus 1 y of minus 1 plus y of minus 2 is equal to the z transform of x of n is 2 into x of z, right, plus 3 by 2 into the z transform of x of n minus 1 is z raised to minus 1 x of z plus x of minus 1. Okay, So now I applied my Z transform. So this is what you need to understand first. If you are going to find the transfer function h of Z or its inverse impulse response, if you're going to find the transfer function or impulse response, you need not consider the initial conditions. That means all initial conditions will become zero when you are going to find the transfer function or the impulse response. Okay, therefore neglecting all initial conditions, the above equation will become y of z minus 3 by 2 z inverse y of z plus 1 by 2 y of z, I forgot to write this, into z raised to minus 2 is equal to 2x of z plus 3 by 2 z inverse x of z. Okay, so this is how the equation will become, right? So remember that if you are going to find the impulse response h of n or the transfer function h of z, then you should automatically put all initial conditions equal to 0. Okay, even though they have given the initial conditions in the question, all initial conditions must be 0 when you are finding the impulse response or the transfer function. All right, when you're finding h of n or h of z, the initial conditions must all be put to 0. Okay, so I got this equation. Now I'm going to find y of z by x of z, and that is my h of z. So I will take y of z common. It will become 1 minus 3 by 2 z inverse plus 1 by 2 z raised to minus 2 is equal to, and I will take x of z common over here. It will become x of z into 2 plus 3 by 2 z inverse. Okay, so therefore y of z by x of z is equal to, this is the numerator, 2 plus 3 by 2 z inverse by, and my denominator is 1 minus 3 by 2 z inverse plus 1 by 2 z raised to minus 2. Okay, so this is my h of z, or this is equal to, I can write like this is equal to h of z. Okay, so now here but the powers are all in negative, right? The powers of z are all negative, so I'm going to make all the powers of z positive. So in order to make it positive, I will multiply both the numerator and the denominator with which one? Yeah, minus 2. So I will multiply both the denominator and the numerator with z raised to 2, z square. So multiplying both the numerator and denominator with z square, I will get h of z is equal to, here it will become z 2z square plus 3 by 2z by, here it will become z square minus 3 by 2z plus 1 by 2. Okay, so this is how we find it. Okay, so now maybe I will take this z common right over here. So this equation will basically become z into z plus 3 by 2 by, here it will become, how to factorize this, z square minus 3 by 2 z plus 1 by 2, right? So finding two numbers in which if you add them you will get minus 3 by 2, and on multiplying them you will get 1 by 2. So what are those two numbers? It will become 1 and 1 by 2, right? Minus 1 and minus 1 by 2. So minus 1 and minus 1 by 2, because minus 1 plus minus 1 by 2 is minus 3 by 2, and minus 1 into minus 1 by 2 is 1 by 2. Right, so therefore you can factorize this denominator as z minus 1 into z minus 1 by 2, and this is how we found the value of h of z. Okay, so now I found the value of h of z. So So now the next thing is I'm going to factorize this. So before factorizing this, I need to preserve that z. I need to preserve one z at the denominator. So this will become h of z by z is equal to z plus 3 by 2 by, this will become z minus 1 into z minus 1 by 2. Okay. So now I'm going to factorize, apply partial fraction over here. So this will become a by z minus 1 plus b by z minus 1 by 2. So now I'm going to find the value of a and b. So to find the value of a, the denominator of a is z minus 1. So remove z minus 1 over here. So the remaining expression will become z plus 3 by 2 by z minus 1 by 2. And then I'm substituting the value of z as z minus 1 is equal to 0. Therefore, z is equal to 1. So substitute the value of z is equal to 1. Okay. So you will get over here 1 plus 3 by 2 by 1 minus 1 by 2. 1 plus 3 by 2 is 2 plus 3, 5. So 5 by 2 by, here is 1 minus 1 by 2 is 1 by 2 itself, and 2 and 2 will get cancelled. So your answer will be 5. So the value of A is 5. Next I'm going to find the value of B. To find the value of B, the value of Z should be Z minus 2 equal to 0. So Z is equal to 1 by 2. Okay. And here the denominator is Z minus 1 by 2. So remove Z minus 1 by 2 over here and write the remaining values. Z plus 3 by 2 by Z minus 1, where Z is equal to 1 by 2. Okay. And here I'm going to substitute 1 by 2 plus 3 by 2 by, here it will become 1 by 2 minus 1. Okay, so 1 by 2 plus 3 by 2 is 4 by 2, right? 4 by 2 by, and this is 1 by 2 minus 1 is minus 1 by 2. So 2 by 2 will get cancelled, you will get minus 4. Therefore the value of A is 5 and the value of B is minus 4. Substitute that over here, you will get h of z by z is equal to 5 into 1 by z minus 1 plus minus 4 into 1 by z minus 1 by 2. Okay, so you'll get this. So now I'm going to put the z back to its numerator, right? This preserved z. So therefore h of z is equal to 5 into z by z minus 1 minus 4 by z by z minus 1 by 2. Okay, so therefore your h of n is nothing but 5 into z inverse of z by z minus 1 minus 4 into z inverse of z by z minus 1 by 2. Okay, and this is nothing but, so 5 into, and what is z transform of, what is z inverse of this? It is 1 raised to n u of n minus 4 into, and the z inverse of this is 1 by 2 raised to n u of n. Okay, 1 raised to n is 1 itself, so you will get 5 u of n minus 4 1 by 2 raised to n u of n, right? In other words, h of n is equal to, I can take u of n common out, it will become 5 minus 4 into 1 by 2 raised to n u of n. So this is my h of n. This is the answer for the first part of the question, right? First part of the h of n. Okay, so let me remind you once again that in order to find the impulse response, right, when you're going to find the impulse response, or when you're going to find the transfer function, either h of z or h of n, the transfer function or the impulse response, don't forget to put all the initial conditions equal to 0. Okay, you should, all the initial conditions must be made to 0. Even though they have given the initial conditions in the question, don't forget to put all the initial conditions to 0. Okay, you are going to use the initial conditions only when you want to find the output when you are going to find the y of n, or when you are going to solve this difference equation, right? So solving the difference equation only you are going to apply the initial conditions. Okay, so let's do that question. So now we are going to do the second question. Okay, find the output y of n, right? So so let's do the second question right now, the second part of the question. Okay, let me write the question again. Given y of n minus 3 by 2 y of n minus 1 plus 1 by 2 plus 1 by 2 y of n minus 2. So 1 by 2 is equal to 2 x of n is equal to 2 x of n plus 3 by 2 x of n minus 1 plus 3 by 2 x of n minus 1. Okay, so this is the question. So now I'm going to apply my Z transform to this question again. So applying Z transform to the above equation. So this will become y of z minus 3 by 2. The z transform of y of n minus 1 is z raised to minus 1 y of z plus y of minus 1 plus 1 by 2, and the z transform of y of n minus 2 is z raised to minus 2 y of z plus z raised to minus 1 y of minus 1 plus y of minus 2. Okay, plus y of minus 2 is equal to the z transform 2 into the z transform of x of n is x of z plus 3 by 2 into, and the z transform of x of n minus 1 is z raised to minus 1 x of z plus x of minus 1. Okay, now to find the output y of n, I am going to apply my initial conditions as given in the question. Okay, so applying initial conditions, applying initial conditions and the initial conditions given are, let me see, y of minus 1 is equal to 0. So that makes the question more easy. Y of minus 1 is equal to 0, comma, and the next question is y of minus 2 is equal to 1. So y of minus 2 is equal to 1. Okay, do we need any other initial conditions over here? I have the value of y of minus 1, I have the value of y of minus 2, and x of minus 1. X of minus 1 is not given in the question, so I can assume that x of minus 1 is equal to 0. Okay, so these are my initial conditions I'm going to apply in the above equation. So this equation will become y of z minus 3 by 2, and this will become z inverse y of minus 1 is 0, right? So z inverse y of z plus 1 by 2, and this will become z raised to minus 2 y of z, okay, plus y of minus 1 is 0, but y of minus 2 is 1. This value y of minus 2 is 1, so it will become plus 1 is equal to, and here it will become 2 into x of z plus 3 by 2. X of minus 1 is 0, so this will remain 3 by 2 z inverse x of z. Okay, so this is how we get. Okay, now I need to simplify this equation a little bit more. So what I'll do is I will this is one term, here there are two terms, so I will cross multiply this with inside the bracket, right? I'll apply 1 by 2 inside the bracket, so this will become y of z minus 3 by 2 z inverse y of z plus 1 by 2 z raised to minus 2 y of z plus 1 by 2, right? Plus 1 by 2 is equal to, here I will take here I'll take is x of z common, right? Or I'll do that in the next step. 2 into x of z plus 3 by 2 z raised to minus 1 x of z. Okay, so now I'll take y of z common over here and x of z common over here. So this equation will become y of z into 1 minus 3 by 2 z inverse plus 1 by 2 z raised to minus 2. Okay, and this 1 by 2 I will put it in the other side of the equation, so it will become equal to minus 1 by 2 plus, and this x of z I will take common, so x of z into, this will become 2 plus 3 by 2 z inverse. Okay, 3 by 2 z inverse. Alright, so now I'm going to find, so now we have already seen that the value of x of z, right? That is, the equation for x of n is already given, right? X of n, what is the equation for x of n? The equation for x of n is 1 by 4 raised to n u of n, right? So x of n is equal to 1 by 4 raised to n u of n. Okay, and since this is the equation, then in that case x of z, right, x of z is equal to z by z minus 1 by 4. This is the z transform of x of n. So I'm going to substitute this x of z in this equation. So this equation will become y of z into 1 minus 3 by 2 z raised to minus 1 plus 1 by 2 z raised to minus 2 is equal to minus 1 by 2 plus, so x of z is z by z minus 1 by 4 into 2 plus 3 by 2 z inverse. Okay, so this is the equation I got, right? So now I know how to find the y of z, right? So y of z is equal to, this is minus 1 by 2 by, this is 1 minus 3 by 2 z inverse plus 1 by 2 z raised to minus 2 plus, and the other one is z into 2 plus, not 2, I think it is z, right? Let me check. No, it is 2, yes. 2 plus 3 by 2 z inverse. Okay, just check over here. Here it is 2 plus, yes, 2 plus is 3 by 2 z inverse by, and here remaining is z minus 1 by 4, and this value 1 minus 3 by 2 z inverse plus 1 by 2 z raised to minus 2. Okay, so these are the two terms. All right, so just to make this more simpler, what I will do is I will, here there are negative powers of z, right? So I will multiply both the numerator denominator with z raised to 2, right? So I can remove this. So z raised to 2, multiplying both the numerator denominator with z square, you will get, this will become minus 1 by 2 z square by, this will become z square minus 3 by 2 z plus 1 by 2 plus, and this will become z square, right? So multiplying with z square, this will become z cube into 2 plus 3 by 2 z inverse by, this will become z minus 1 by 4 into, and this will become z square minus 3 by 2 z plus 1 by 2. Okay, so this is what you will get. Okay, so now I'm going to factorize these two, right? I already know the values for the factorization, right? It is z minus 1 and z minus 2. It is z minus 1 and z minus 1 by 2. So this will become, so this I can write this as minus 1 by 2 z square by, this is z minus 1 into z minus 1 by 2, plus this is z cube into 2 plus 3 by 2 z raised to minus 1 by, this is z minus 1 by 4 into z minus 1 into z minus 1 by 2. Okay, so you got this. Okay, so now I will take, maybe here also there is an z raised to minus 1 over here, so I'll take one z from here and multiply it inside this so that I can remove this z over here, right? So this will become minus 1 by 2 z square by z minus 1 into z minus 1 by 2 plus, and this will become, so this will become